Hi everyone, my name is Nick Chalon. Thanks so much for joining this next episode of In the Nick of Time. We're going to get started in about 10-12 minutes now. Stay tuned for this next episode on the Service Mesh with Zack Butcher from Tetrate. We're going to get started 12 minutes. Stay tuned. Just hold on with a little bit of music. Good morning, good afternoon, everybody. This is Nick Chalon. Thanks so much for joining us in the next episode of In the Nick of Time. First, I'm going to apologize for my voice and probably my face because I'm sick. I have the flu, but we'll survive. So thanks so much for joining us. We're going to get started in about 10 minutes. If you have questions for Zack on Service Mesh and how you can deploy a Service Mesh across your organization and what kind of impediments you're going to be facing doing that, federation of meshes, how to scale, how to delegate policies across the enterprise. So many great questions, so many points of discussions today with Zack Butcher from Tetrate, part of the team that created Istio, the service mesh that just announced will be hopefully now part of Cncf as well. So stay tuned. We're going to get started in about 8 minutes. Good afternoon and good morning, everybody. This is Nick Shalom. We're going to get started in about 5 minutes now in the next episode of In the Nick of Time with Zack Butcher from Tetrate, part of the team that created Istio, the service mesh. If you have questions, please make sure you ask the question starting with a Q so we know it's a question in the comment section below. Also, if you want to share you here, put your name and company so we can highlight you on the screen as well. We're going to get started in about 5 minutes. Thanks so much for joining us. Good morning, good afternoon, everybody. This is Nick Shalom. Thanks so much for joining us in the next episode of In the Nick of Time. Today, we're going to be talking technology again with Zack Butcher on the service mesh Istio and all the work he's been doing for the last many years now. First at Google and now at Tetrate as the head of product. First, before we get started, please make sure you register to the mailing list in the nickofTime.tv if you have not done that, so you can get the notifications for the show. We are also releasing technical videos every week now. We just did that last week with the video on SpaceX versus F-35. That was pretty cool. What is the kind of the key metrics to compare the velocity and the delivery of capabilities in real time multiple times a day with SpaceX versus 7 years with F-35. If you missed it, take a look at that video on the YouTube channel of the In the Nick of Time YouTube page. You will also see this week a new video on the how to beat the the ability to release, and you'll see kind of how we are pushing to go past the Valley of Death. So the Valley of Death, of course, is something that's being really pushed from the DoD officials in the last few months now, and you'll see that we're bringing a few key concepts to ensure that we can finally get rid of the Valley of Death when it comes to transitioning programs from the DoD to the commercial side, but also across the department at a broader scale as well. So that's going to be the next video coming this week as well. So if you've not subscribed to the channel on YouTube and you have a YouTube account, do that at youtube.com/Nick Chillon, Nicolas Chillon as well. Thanks for the first 1,100 subscribers we got in the last month. Pretty exciting as well. We launched also a newsletter on LinkedIn. If you've not subscribed to the newsletter, you can do that as well. You'll get kind of the same content that you get through the LinkedIn posts we do every week, but summarized into a single article once a week, so you can get access to all of the news that you may have missed in cyber, DevSecOps, innovation, and of course, national security with DoD as well. All right, so now we're going to get into the real meat of today's discussion with our special guest, Zach. I'm going to bring him on the screen. Good morning, good afternoon. How are you doing?
Hey, I'm doing great. Thanks for having me. I'm excited to be here.
Yeah, so excited to have you. We worked for many years together. First, when I was in the department, and you've helped us, of course, for many years to start to understand a little bit better the power and the importance of Istio and the service mesh. For people that don't know you, you're one of the founding engineers of Tetrate. You are the head of product right now. You have obviously came from Google, where you were part of the team, one of the first people part of the team to also join the steering committee and of course contribute heavily in Istio. You co-wrote the book Istio Up and Running, and more importantly, I guess for people here, you've been working with NIST now for many years to publish the special publications, the 800-204 series A, B, C, really going after microservices, understanding DevSecOps, and all the good stuff. So it's pretty exciting to have you on the show. Before that, of course, like I said, you were at the Google Cloud Platform, and of course the Google internal mesh that Istio came from, and like Cubase, I guess everything at some point came from Google, I guess somewhere. And for people that want to follow you, you're on Twitter, Zack Butcher, and you're also, of course, on LinkedIn. So before we get into the meat of the discussion, I always love to let you give a quick introduction and tell us a little bit about your journey before we get started.
Yeah, thanks. And so it's kind of funny. I don't think we talked about that too much, Nick, but maybe a funny small world. Of course, the executive order came out last year that really helped push Zero Trust, which is an area I've worked in for quite a few years now. But I started my first job while I was still in school, was working for that oil pipeline company, Colonial Pipeline Company. That was the reason that we have that executive order. I didn't do security for them. But I cut forward a little bit, and like you mentioned, I worked extensively at Google, across Google Cloud, in a bunch of kind of what I would call maybe the enterprisey parts of Google Cloud, such as they are, the central resource hierarchy, the identity and access management system, and that led pretty naturally then into working on the service mesh there inside of Google, as we were first kind of pushing this architecture. And in that time, Istio started to become really, really successful. We started to see a lot of adoption and a lot of interest across the industry, but it wasn't quite being oriented to solve the right problems in our mind. In my opinion, and then Varun, who started Tetrate, it was primarily around the difficulty in bridging environments and in how do we actually, establish a secure baseline that we can start to build our infrastructure on top of, regardless of whether it's in cloud or in a data center or where things are running, right? And so that kind of kernel was the reason that we went and started to build the company Tetrate. That had been 4 years ago. I'll be 4 years at Tetrate this month, actually, just a few days. To really bring the service mesh to enterprise and help solve these problems around application identity, large pieces of runtime security, as well as empower application developers to go move more quickly, because we can pull these concerns out of the application and into the mesh. So it's a really exciting set of technologies to start to work on, and we built this company around it, starting about 4 years ago. Like you mentioned, Nick, out of that, we started to collaborate with the DoD and with the Air Force on Platform One. We started to collaborate as well with NIST to help write. Originally, actually, we collaborated on access control. I mentioned I did some research on access control. I work really closely with the folks over at NIST on next generation access control, which I think maybe we'll talk about kind of at the end of today. It's really exciting. And out of that, we started to write then these SPs, the SP 800-204 series, that focuses on service mesh security, and not just service mesh security, but microservice security, and using a service mesh to achieve it.
Yeah, so much to talk about, but I guess maybe before we even get close to that, for people that maybe have been sleeping for the last 3 years, what is a service mesh?
Yeah, so it's really the realization that if we look at distributed systems today, there's a whole bunch of concerns that you need to address. You need to address, how applications communicate with each other, how they secure that communication with a strong identity and encryption in transit, how you can apply policy to that communication. And the service mesh is a pattern to help facilitate that. The core idea is that we intercept all the traffic into and out of your application by putting a network proxy right next to it. We use Envoy as the proxy of choice in Istio, which is another Cncf project. And because that proxy intercepts all the traffic in and out, it can become this policy enforcement point for us, where we can do encryption in transit, where we can start to implement a lot of the controls that you might need to realize a zero trust architecture, and also start to meet application developer needs to do things like canaries and blue-green deployments, improve application resiliency, and finally tie it all together with pretty good observability for the operations of your application, which services are talking to which other services, how much with what errors, so the operational view on your infrastructure. And so it's a really incredibly powerful tool sitting at that network layer, intercepting all the traffic in and out, for implementing security policy and enabling developers in an organization.
Yeah, so, obviously teams moving to microservices start to feel the pain, right? Having to, initially before service mesh, I guess, share libraries and dependencies across teams, and having to figure out how to do service discovery and authentication and encryption, all the stuff you talked about. And so the beauty, I guess, of a service mesh is also kind of to decouple, right, all these principles, right, and so it's injected as a sidecar container using the proxy Envoy, which is also part of Cncf. Maybe tell us a little bit about what is a sidecar concept, and how would you also explain what Envoy does?
Yeah. So the idea you're exactly right, Nick. So the things that I just talked about are required for a distributed system, regardless of how you achieve it. And the way, and historically, we've had frameworks like Hystrix and the Netflix libraries, Spring Boot, and that family of tools as well to help like implement this kind of behavior in the application itself. But then you're coupled to the application lifecycle, and your test becomes a lot harder. The maintenance becomes a lot harder. Update becomes a lot harder. Change becomes a lot harder. So one of the key ideas is to pull that functionality out of the application itself and into a separate process. And because that separate process sits next to every instance of the application, we call that a sidecar. You can think about it, this is a network sidecar, but you've probably run log collection jobs as a daemon or as a sidecar to your applications for years, right, on VMs into modern Kubernetes infrastructure as well. Things like Fluentd, right, as a different kind of sidecar. And so when we're talking about then the sidecar, that separate process that implements all the network behavior, all the mesh behavior, what do we use to do that? And like Nick said, we use Envoy, which is a network proxy. And so you can think of Envoy as very similar to something like an Nginx. But the key advantage to Envoy is that it's very lightweight to run. So we can afford to put a copy of Envoy beside every application instance. And it's highly dynamic and configurable at runtime. So we can change the behavior on a whim. And we can drive that behavior with configuration that we own and manage as code. And that's really the key thing that the service mesh gives us. It separates the lifecycle of this functionality from the application, and it lets us control it centrally with infrastructure as code.
So you also talked about the fact that Envoy is lightweight and can be injected effectively, easily as a sidecar. A lot of people, and we'll get to Ebpf and all that in later, but before you even get to that,
a
lot of people still argue, right? Why would you run this stuff as a sidecar versus like maybe a daemon set per node?
Mm-hmm.
And so how would you explain the benefits of using a sidecar model versus maybe something per node or a different model?
Yeah, and the answer is it's a set of trade-offs, right? We have to use kind of our engineering design decision here. There is not a clear categorical winner. However, there is a reason that the current service mesh implementations are focused on the sidecar pattern, and those trade-offs are really in three dimensions. First and foremost, we're using that sidecar proxy to present the application's identity on the network. We'll talk about that, but one of the key things that the service mesh provides is an application identity as an X509 certificate that we can authenticate at runtime and use for encryption. If you have one proxy per application, then the identity mapping is really easy. It's one-to-one. When you only have a proxy on the host, and that host is running potentially multiple applications, right? In Kubernetes, we might run 20 or 30 pods on the same host. Then that proxy might have to hold 20 or 30 identities. And you need to make sure that it uses the right identity for the right application. There's a mapping there. Generally speaking, this is called the confused deputy problem, right? So we have the Envoy has a set of credentials. It is relatively straightforward for an application to trick Envoy into using the wrong credential, making it a confused deputy and escalating the privileges of that application. So that's one reason that you might choose a one-to-one sidecar deployment model versus a host. The second one is you have a shared failure domain. All the configuration for all the applications need to go on one Envoy instance versus going to one Envoy instance per application. And so where you have that shared configuration, you have the opportunity for a shared outage. So we have shared fate failure. And then third, we have noisy neighbor potential. Now, even in a sidecar model, you can have a noisy neighbor on the same physical host at the CPU level. But we're talking about a noisy neighbor even inside of Envoy itself at the software layer too, because it's not, it doesn't have robust internal application controls to help ensure fairness. So for those three reasons, the confused deputy, shared fate outages, as well as noisy neighbors, we like to use a per application sidecar deployment model as opposed to a per host deployment model. And then, later we'll talk about Ebpf or not. And that's really, I think of as acceleration. How do we make that sidecar or the host-based proxy faster or cheaper?
Yeah, no, that's a good summary. So usually we take questions at the end, but there's a question I guess we could take now from Rajesh about what's the difference between a service mesh and RASP, and what's the difference between the two, I guess.
And I'm actually not super security with RASP with the RASP. So why don't you, Nick? Why don't you summarize that for me real quick, if you don't mind?
Yeah. Well, I guess the runtime application self protection is kind of doing a lot of the runtime instrumentation, to detect kind of what's going on, and so you have a lot of RASP solutions out there, but they I guess they're on the runtime side. They're not really acting as a mesh. It's more like a cyber principle. So it's a very different side of the house, but it's, I guess, to some degree, there's a lot of overlap in terms of what you could potentially do. But I guess the difference is how it will be injected. And, it will not be something used by developers as much as cyber guys, right? So I think, I guess service mesh is the primary consumer is a developer. But the cyber guys, of course, get tremendous value by having the zero trust enforcement and the injection of the mutual TLS tunnel and the policy enforcement stuff and everything as code. So I guess that there's that aspect. And so there's kind of both personas for the service mesh versus, I guess, the RASP stuff would be mostly the cyber guys. And it will not be able to kind of solve all the other pieces of a mesh, like the service discovery, routing, canary releases, all that stuff.
Yeah, and so if we start to talk about some of the application protections and application level policy and some of those things, we actually do make the case in SP 204 800-204B that you do want to start to pull those out and use the mesh as your enforcement point rather than enforcing them in the application itself, because then it can be audited. It's a one consistent layer. You can manage it centrally, all of those kind of core mesh benefits. In terms of the kinds of policy, you're exactly correct. We can do application-oriented policy in the mesh because we're processing the traffic at layer 7. So I can look at individual requests. I can do things like write a WebAssembly program or use built-in functionality in Envoy to inspect the request and make policy decisions on it. For example, mod security, which is one of the more popular open source web application firewall frameworks, has been incorporated into Envoy, so you can start to implement WAF style controls, even at the sidecar rather than just at the edge.
Yeah, no, absolutely. So let's talk a little bit about Envoy, right? I got into a little bit of trouble this weekend by tweeting, because I'm tweeting now. It's fancy, So I tweeted about the fact that Envoy is winning the war on the policy enforcement points, and of course LinkedIn was not too happy about it, but that's okay. So why do you think Envoy is at least very very succeeding very well when it comes to PEPs?
I think that there's a couple different reasons for it. So one is, if you're going to look at something that's going to be a policy enforcement point, generally, you want that code base to be something that's you want that code base to be well audited. You want a lot of hands in it. You want quite a few different parties involved in it, right? You don't want one single group controlling it. That's one of the reasons that Envoy is so compelling. It's basically.
Can you tell us more about who is contributing, I guess, to Envoy right now?
Yeah, great. So, Lyft is the company that created Envoy, but there's a ton of contributors. Tetrate is one of the larger contributors to toot our own horn, as well as folks like Google, Apple contribute to it. Folks like VMware use it for their own service mesh as well, which is based on Istio. We're seeing folks like eBay, for example, who don't even use a service mesh but just use it as a traditional proxy. So we have. Basically everybody that's doing cloud native stuff is converging on Envoy as the proxy of choice because it's performant, it's lightweight, and like I mentioned earlier, it's highly configurable and highly dynamic at runtime. So because of those, it's really clearly winning out, and therefore development energy is going into it, and it just has more capabilities, more hands on the project than some of the other proxies that are in some of the other meshes built on their own proxies that exist in Cncf.
What would you say that someone would use Envoy as a proxy and not as a service mesh? Back to
Yeah.
your comment on that company.
When you just really want a really good proxy that's highly dynamic in ways that Nginx isn't, right? So if you think of those like traditional Nginx use cases or HA proxy use cases, and even actually we're increasingly seeing some lightweight API gateway functionality. So, I just want to do rate limiting and I want to validate a token and I want to do load balancing, right? That is a perfect fit for Envoy as a sidecar or as an ingress proxy standalone, like a traditional proxy deployment.
Right.
And so we're seeing it widely adopted. One other thing I'll just point out, because I know we have a security focused audience, is that one of the big advantages for Envoy is that, the Cncf funds, as well as Lyft and Google, and I think maybe even Apple as well, all fund bug bounties on Envoy on the code base. And it has a really mature and well-exercised CVE notification and patching process. And so it's a really mature code base, it's a mature community, and there's a lot of large players that are all involved to make sure that it'll continue to be successful in the long term.
Yeah, and funny enough, I was with F5 in the last few weeks, and I can tell you even F5, who just recently bought a company around Envoy, decided to move and to fully adopt Envoy as a capability and make it a product too. So even the people behind Nginx are all deciding to move to Envoy. So, all right. So we talked about Envoy. Big news that I broke, because I like to break news before everybody else, last week. Google was not too happy, but that's okay.
No.
Istio is being donated to Cncf. Tell us more about why we've been trying to push this for years now, I don't know, and why it matters.
Yeah, literally for years. And I think there's a lot of things there's a lot of aspects where this matters and somewhere it doesn't. So one thing I want to be really clear with people is that Istio being in the Cncf doesn't really change the governance. Istio has had an open governance. It's actually, like I mentioned, Envoy has a very diverse set of contributors and companies that contribute. Istio does as well. And so the governance side of it doesn't change. Instead, what does change is that the mark is going to be held by a neutral body. And really the biggest impact is that it kind of has the Cncf's kind of seal of approval once it is accepted in. And it kind of puts to bed any of the debate around, is Istio part of the cloud native stack or not? The answer is it is de facto part of the cloud native stack. And this kind of formalizes that. We've wanted it for years because it just lowers any other remaining barriers or reservations around adoption, right? Istio has been the most widely deployed mesh. It's by far the most featureful mesh. It's gone in the most places. Folks like, Platform One within the DoD leverage it for runtime security. We know it's a solid piece of software. This kind of checks a lot of organizational boxes and kind of finally brings Istio kind of into the fold alongside Kubernetes and Envoy and a lot of these other projects that it leverages.
Yeah, no, absolutely. And, I think a lot of people see it as a kind of a good way to demonstrate that what they are picking is the right option. So seeing it's kind of validated, or at least part of Cncf, is a big deal. So
exactly, you'll start to see it appear in things like the Cncf security landscape more prominently. That opens up the door for a lot of those other things. But you're exactly correct.
Yeah, although it's getting to be maybe a little bit bloated. I don't know.
I would love to see like
the schema, right?
Stacks. Yeah, I would love to see like opinionated recommended Cncf stacks come out and kind of be pushed, because I think that's really what the industry needs right now, because it is such a large landscape.
Isn't that pretty much what all these Kubernetes distributions are doing nowadays anyways?
Exactly. It's de facto happening. So, hey, why don't we go ahead and just make some general recommendations so we can start to build security models around it and practices around it and that kind of thing.
Yeah. All right. So I've worked a lot with NIST, and God knows the NIST guys are awesome people. And you got the chance to also collaborate with those guys on the 800-204 series. I did also other, work with NIST also on the cyber framework and other stuff. Yeah. Tell us about what the series is about, and what are the different documents, and kind of what was the idea behind writing these?
Yeah, so the job of the 800-204 series is really to help advise and set recommendations on microservice security. So it's not, a service mesh security publications or anything like that. It's much more general than that. It's really about microservice security, and especially in cloud environments. And so there are four publications in the series so far, and I do expect that we'll continue to publish them as long as they're continuing to be valuable for folks, right? And so of those four, 800-204 itself, the first one in the series, outlines really just, I believe, about 13 or so high-level security strategies that you would want to pursue when you're looking at a microservice-oriented architecture. 204A then starts to make it a little bit more concrete by starting to recommend some specific controls around a service mesh and using a service mesh to realize some of those strategies that we talked about in the first. 204B doubles down on that, and it really builds out the idea of Envoy as a universal policy enforcement point. What we just talked about a little bit earlier, the idea that Envoy becomes the place where I can focus my policy. And with Envoy as that policy enforcement point, then the service mesh as a whole becomes our security kernel. It becomes the kind of key place where we go to for security, that we audit. It becomes the high assurance part of our system. And it frees the applications from having to worry about those things. And we discuss how you can even pull functionality like end user authentication, even potentially end user authorization to access specific resources out of the application itself and into the service mesh. This is a really, really powerful idea. And then finally, 204C brings this into DevSecOps more fully and starts to address not just the runtime parts of Zero Trust, but what I like to call the pre-runtime. What does it take to produce a code artifact? What does it take to take that artifact and run it in production? And what are the pipelines and processes there? And how do you create security and assurance as you move through those?
Yeah, so it's too bad that I think we didn't promote these publications well enough, because I think most people have never heard of them. Most people focused on the cybersecurity framework and all that kind of body of work from NIST, but
which is
these
great.
are pretty amazing publications.
Yeah, thank you. No, and I love the cybersecurity framework. It's good that you mentioned that, because that's actually some of the stuff we're working on now, which is kind of doing mappings between the cybersecurity framework, the CSF, and Istio itself, as well as, there are already existing mappings to 853, which we think of as kind of the granddaddy of control documents, right? And so I'm hopeful that when we start to make these links, it'll become more obvious for people that, hey, these are valuable. And we definitely need to go do better marketing around them, because, we wrote these with the intention that they would be used. And I think hopefully they're a little bit more practical and a little bit more hands-on than maybe a lot of the NIST guidance that you read. In part, that's because we were able to do it at the same time that we were actively helping enterprise, as well as folks like Platform One and the DoD, actually implement this stuff for real.
Yeah, no doubt. And we'll do better at promoting them also on LinkedIn. So let's do that.
Yep,
All right. So now that leads us to kind of, something you've been working on for a long time now, what you call the next generation access control, NGAC. People know about ABAC, attribute-based access control. People know about RBAC, role-based access control, LBAC, label-based access control. What is next generation access control? That sounds like next generation firewalls, a whole bunch of scam that the firewall companies tried to sell to us. So is that another scam, or is that actually real this time?
No, so this is real, fortunately. And NGAC is a really awesome piece of technology. So it was actually developed by Dr. Ferriolo in NIST, and I actually happened to meet him a few years ago, the day after he received the IEEE Lifetime Achievement Award for the creation of RBAC. Right. So this is a guy that's been foundational to the access control world for decades now, his entire career. He's getting close. In the next couple of years, he'll retire, and it'll be a big loss for all of us.
Huge.
Yeah. And so, David, you mentioned RBAC. That was some of his first work, was help standardizing RBAC and the RBAC patterns and things that we've been using, that have become the industry standard. David then went and helped create ABAC, and in particular the XACML spec and that definition of attribute-based access control. And it was wonderful and powerful, and he hated it. And he hated it, and because, and I think this is rightly, it's too loose. You have to basically come up with your own rules to keep things safe. Therefore, it is very hard to do policy authorship. It's hard when you write a policy to know what the effect is going to be. And so he and his team sat down to try and formulate an access control system that was as powerful as attribute-based access control, as XACML, but was easy to understand and author, and built in primitives from the very beginning that had been missing in existing access control systems to help us understand. So the idea, for example, audit, what will a policy do? What will the effect of a policy be before I apply it? As well as explain, which is why was a decision allowed or disallowed, are actually like native primitive operations that are built into the access control system. And the whole system is geared around giving like human understandable, human readable answers to those questions. So it's a lot easier to understand. It's a lot lower conceptual burden. It actually also happens to have better runtime performance as well, which is another nice win, than traditional XACML-based ABACs. But NGAC itself is, at the end of the day, an attribute-based access control system. So anything that you can do in a traditional XACML, for example, ABAC, you can do in NGAC as well. So it's incredibly powerful, but it has this understandability and explainability that it's lacking in traditional ABAC. And we can dig into why. The fundamental difference is that it's a graph-based access control system as opposed to being a set theoretics-based. And because of that, you get a bunch of really good properties. We can go into the details, but that gets into like math research.
No, that's great. So when you look at that graph model, right, that gives you the ability to understand better the policies and kind of explain it. Is that explaining visually or textually, or how does someone get to understand better what the policies are going to do?
Yeah, and the answer is yes, both, right? And so we show it, and this really gets into how you implement the NGAC. So one of your other questions was, is it real or not? It is real. It's actually an ANSI standard. And so you can go and get the standard document for NGAC that describes how the system works, what the operations are to be a compliant NGAC implementation. And so it is a real and standard thing that you can go and grab. And there are, however, different implementations today. And this is where it's still a little bit early days for NGAC. Really what we're trying to do today is raise awareness of NGAC as a mechanism. And we think in time it'll supplant ABAC and probably RBAC as well eventually. And we want to get it there. And so this, we're in the early days where it's been about a decade now that NGAC has existed, but we're just now getting the first kind of industrial strength implementations of it. We're generating the IP around how we actually start to model real problems in it. And so it's a really exciting time in NGAC where it's really kind of ready to start to be applied to real world problems.
Yeah, and we're lucky today because we have Michel Toupin from the Ministry of Defense of Canada
awesome.
Joining us too. And so he's answering all your questions, so you don't have to do it.
Yes, great. I saw it, which is phenomenal. I love it. I was sitting here watching it and going, "Oh, this is great."
Yeah, Michel is awesome. So, all right. So when you take a look at the implementation of NGAC, right? Are you saying also like Tetrate as a company is going to be kind of bringing this to life, or is that not a priority of the company right now?
Yeah, we are. So, for us, we look at it as two things. So first, you need that policy enforcement point. And then once you have a policy enforcement point in place, that service mesh, then we can start to use technology like NGAC, but also other technology around, as a stopgap today, we see OPA used for very similar policy that we'll eventually, I hope, see migrate into NGAC. So for us, we are building out that industrial implementation. We use it to power our service mesh product today as a way to make sure that the implementation is robust and that we built it out and it's solid, with the intent that we'll take it into market in the next little bit. I don't have a firm timeline, and I expect we're going to see others as well, because this is open. These are open specs and open standards, and the technology itself is incredibly compelling for folks that are in the access control space. I would say go read some of the white papers on it. Go read the spec. It is some really compelling and groundbreaking stuff.
So when you look at this kind of scale you need, right, for large organization to start using something like a graph-based technology, what kind of tech stack did you bet on for the graph piece to bring that graph technology into your product?
Yeah, so for us right now, we're actually doing a lot of it in just simple KB stores, and the graph kind of lives in the application itself. We did this because there's a couple of kind of specialized traversals that you do in NGAC that we decided to hard code. And one of the cool things that we've seen there is that the scale that you can go to with a system like that is large. This is one of the things that's really compelling about NGAC in general, is that it's a rather efficient, you can get really efficient representations. So you can have, production scale graphs on a single machine pretty trivially. When I say production scale, I'm talking, hundreds of millions of resources, hundreds of thousands of users, kind of scale can fit on a single pretty modest machine, right? And so as yet, we haven't had to pull in heavier weight, graph databases and similar. When we do, we'll probably start with Neo4j as the technology of choice there, and then continue to build further.
Yeah, funny enough, I actually used Neo4j for one of the companies I sold that was mapping cyber things with business things and contract, and trying to find hidden relationships and trying to see the degree of depth of hidden relationships sometimes when you make decisions, particularly around cyber things, and you don't know that the guy who signed the contract is also the guy who also sold the thing. And it's kind of pretty interesting when you think of insider threat or like unintended consequences, when you think of it as a graph versus like something you would develop as a custom code. That gives you so much more flexibility. Yeah, that's pretty cool.
Hey, that's 100% true. And it's good that you mentioned insider threat, because literally the first NGAC paper is about insider threat, limiting insider threat, right? Because it's incredibly hard in attribute-based access control system to understand the impact of a policy. Therefore, it's very easy to create unintended access and these insider threats. NGAC, the whole formulation, the original motivation is, how do we get an access control system that's robust, lets people do things effectively, but limits the risk there. And so that's perfect.
Yeah. And I guess, when you start thinking of zero trust, right, we think of data-centricity, we think of not only people, person entity, but also non-person entity now with microservices.
Yeah.
And of course, Istio does all that, right? We saw on the questions, Michelle answering like the issuance of certificate, exactly. Istio does that for you, issues the short-lived, certificate for containers to create the mutual TLS tunneling, all that good stuff. And then you can, of course, make sure that authentication, all the good stuff happens there, and you can whitelist the traffic. So that's a user, both the P and the NP side. If you look at the data side of data objects, one of the big challenges we have in DoD, for example, is the labeling of data down to the cell level, right? Where the who could be TSSCI and the what could be secret rel, and based on who you are, you only get to see what you're supposed to see. When we integrated with tools like Kafka or Elastic, we didn't want to put a proxy in front of it to kind of query the system, because then you lose the connectors and all the open source universe around connecting to these capabilities. So we did a pre and post hook, where the pre hook would be able to validate that you're supposed to have access to the resource, and then the post hook will also kind of filter down the results to remove the cell that you're not supposed to see based on who you are, and maybe even the device you're using, based on your access control. Do you see NGAC being a big enabler of the data centricity aspect of this too?
Yeah, it's huge. And in fact, this is actually something that we've already started to work on. And if you go and look at NDAC, which is Next Generation Access Control for Database Queries, it is exactly that, right? It is exactly the application of NGAC as an access control engine to do cell level decisions on data that gets returned. And so this is a huge pain point in industry. It's a huge pain point in the government. And it's required for zero trust. This is one thing I like to kind of bring around. If I were going to summarize zero trust at runtime, there's 5 minimum controls that you need, right? There's more controls that are good. At a absolute minimum, you must be encrypting your traffic 100% everywhere. You need to be authenticating and authorizing workload to workload, application to application communication. And you need to be authenticating and authorizing end user to resource access as well. And that needs to happen at every single hop in your service graph, not just at the front door, right? And so the service mesh, exactly to your point, is a huge piece towards this. And I think we'll see NDAC, which is, next generation access control on data, become a really, really powerful tool for doing that end user to resource access control, including down to the cell level, so that you can imagine there's a world where I query the employee database and I get back a list of employee names, and Nick, you query the employee database and you get the names and the date of birth and the salary, right, based on roles within the company and similar. And we'll see that happen potentially even without the application having to do it. You're exactly right, though, when we get into high data applications, oftentimes we actually want to force this into the application itself rather than to use a sidecar. And so for these cross-cutting technologies like Kafka, for example, we get a lot of mileage out of inserting a bespoke PEP into Kafka itself compared to, for example, using a sidecar. And so I think we'll see exactly that pattern expand with these kind of core data technologies to help facilitate this fine-grained access control. Because that's where a sidecar isn't necessarily a good fit, because the data copies and similar when you're dealing with high volume data.
Yeah, and I guess someone was asking here, Rajesh, about it would be great if you guys did a hands-on workshop, and I think you do. You also have, the academy.tetrate.io, where you have even the first, certified Istio administrator certification, which is very much like, and I hope that's going to end up being part of Cncf with all this Cncf engagement stuff.
That's what we plan to. We hope that it'll happen.
Yeah,
and there's also a bunch of free training there too. So let me just there's
training. There's an Envoy, right? There's an Envoy training. There's an Istio training, but there's also on your GitHub repo, I believe, workshops that you guys do with companies and teams to get started, and with a step-by-step kind of guide. And so you have a lot of training there, right?
Exactly. There's a ton of material there. So academy.tetrate.io is a great place to start. And if you reach out to me personally or to info@tetrate.io, we'll be able to help you out with material if you want to talk to some of the team and see some of the demos hands-on and all. There's also some demo recordings that we can send over for folks like AWS that we've given in the past.
Yeah, awesome. All right, so we talked about NGAC, but now, what's the future when it comes to NGAC plus Service Mesh?
Yeah, and I started to hint at it, right, which is this idea that because we have the policy enforcement point, which is the sidecar for the service mesh, and we have this phenomenal tool for being able to do fine-grained access control efficiently at runtime that's easy to understand and author in NGAC, the two of these together is incredibly powerful, right? And it lets us implement the policy that NGAC brings to bear, fine-grained policies, very specific data, down to the cell level if we want to go there, and implement them without necessarily needing to involve an application if we can leverage the service mesh in front of that application, right? And so this gives us a lot of power to affect cross-cutting change without having to go to every individual application team, right? I think, Nick, you can speak to this, but one of the compelling reasons to pursue the service mesh as a security baseline in Platform 1 was the fact that you have to cope with so much commercial off-the-shelf software, so much legacy software that can never be changed. You have, hardware, physical hardware devices that you need to interact with, all of that stuff where we can't go in and do it with a framework. We can't go in and change the code to implement, to add an NGAC hook to do policy enforcement, for example. And so the service mesh, because it's working there at the network layer, gives us the hook to be able to do that.
Yeah, and that's kind of something we didn't talk about when we talked about the sidecar container aspect, but I think the key aspect is that the fact that Kubernetes is going to be able to inject across the entire stack, and so you don't have to reach out to all the teams to convince them to run your little bit of cyber capabilities. It's just injected as a reverse proxy, so it doesn't tamper with the way the application is going to behave, other than controlling the east-west traffic and egress if you want to do that.
Exactly.
And people now, of course, use Envoy as well as an ingress controller on Kubernetes. So now you have kind of the same kind of enforcement across the entire enterprise. And if you move to policy as code and everything as code and GitOps, you now have that kind of a centralized cyber enforcement mechanism and the Zeit state in Git, and you can go back and really see what's happening. That's where I guess NGAC and the ability to explain all these policies will really be a massive enabler, because people have conflicting policies and struggle sometimes understanding why something is not working, right?
Exactly. And that's literally the reason that NGAC was invented, was because of that policy authorship and why doesn't it work, right? And I don't have the way to be able to ask my policy system why it's not working, right? And that's the heart of it. And so, yeah, it's an incredibly powerful system together, right? The service mesh by itself is awesome. NGAC by itself is an incredible tool, but together they give us this capability to be able to start to do policy everywhere that really is, astonishingly powerful. I think it'll let us do really amazing things.
Yeah, so I got also a little bit of trouble, because I love to do that, as you know, when I said that it's impossible to succeed in 2022 and beyond without a service mesh if you're moving to microservices at any kind of scale. Of course, if you have two services, maybe you can do it, but with a decent scale and decent team and decouple teams, and more importantly, to enable the decoupling of releases. Am I crazy? Or?
I think so. I will say this: it is definitely possible to do it without a service mesh. I think it is a lot more expensive, or you need to make other trade-offs, right? And those other trade-offs being, you need to have like only one language, therefore one SDK, one framework, or you need to pick only one environment that you'll ever execute in. Like, we're only going to do EC2.
Yeah, you're limiting kind of the point of moving to microservices to begin with.
Exactly. And so it's a really, and I want to touch on the other idea that you're getting at here, which is the idea that the service mesh is this enabler for cross-cutting change, right? We can start to pull horizontal efforts that we traditionally would have to go to every individual application team to achieve, and into this common infrastructure layer. And then we can have one team dedicated to solving that problem, use the service mesh to enable it for the entire organization. And that is a true game changer, because the service mesh begins to act as a force multiplier. And then when we can start to use it to attack, really high value problems like encryption in transit, like service to service access control, and even down to things like how do we safely deploy individual applications, it's really, really strong.
Yeah, and I guess my point is, when I say it's impossible, of course everything is possible, but
it's so expensive, it's not worth it, right? Arguably,
yeah,
right?
The money, the ability to move at the pace of relevance, giving flexibility to the teams to use best technology to get the job done, but also the cyber enforcement piece. Of course, if we forget about cyber and the risk we're facing in 2022, you might say, hey, I can inject all this stuff in a different way, and hopefully it's going to work the same, and we're not going to have drift. We're not going to have teams forgetting to run that cyber thing when trying to run. I argue it would be almost impossible to compete against a team that's using it. So then effectively makes it
Yeah, I mean, just to give some people some idea of kind of the scope of the problem that we're dealing with, we're talking, Istio was created in mid 2016, right? And it has had continuous development in that time. And that's just Istio itself, not even Envoy, the data plane. Envoy, the data plane, is the important part, right? Just Istio itself has had somewhere between 20 and 40 developers per year since 2016 working on it, right? Envoy has had more. And so if you're thinking, and so as you're eyeing up do I build it myself? Do I do some other solution to it? Or do I go with one of these open source projects to achieve it? It would be really, really hard, I think, to justify the expense in doing it yourself when you look at the development time that it takes to take something like this all the way into production. Because the 80% case is really easy, but the 20% case that you really need to close out to hit production strongly and cover all the applications is hard and expensive. And that's true for anything that we do, but it's especially true for these infrastructure projects. And so, if folks are looking at, a DIY or doing it in a non-meshy way, I think there needs to be a pretty large amount of justification for why that decision makes sense in their organization. And in my opinion, the most compelling reasons that would be is because they have a very limited, very scoped down problem that then solve just that one very limited problem, like only Java apps, right? But that's not really the reality of the microservice architecture in a large, complex organization.
Yeah, no doubt. In fact, you're telling us to move to microservices, but you guys did the opposite, right? I remember Istio moved a bunch of microservices to a monolithic Istio daemon. Tell us about why that was the right move.
Yeah, so Istio used to run as 3, then about 4 services there, and the answer is largely that there has to be a bottom. If we think about in math the concept or in type theory, there's a concept of bottom, right? The thing that everything else is built on top of, and so the fact of the matter is that monoliths are easy to operate. That's why we do monoliths. That's why we've done monoliths for the past decade or more. We had SOA for a while. We moved away from SOA and into monolithic architectures, and now we're moving back into microservices. The reason that we do monoliths is because they are operable. And when we're talking about core infrastructure capabilities, operability is maybe the most important feature that you can have because you're using it to run everything else in your infrastructure. And so what we were seeing is that the cost of running Istio itself was high because it was a set of microservices and you couldn't use Istio to run Istio. Therefore, it was a large burden for a team to actually be able to operate. And so we said, look, we know monoliths are operable, but the cost is in the development side. So as a community, Istio will shoulder the increased development cost that comes from a monolithic deployment versus doing it as microservices. And as a benefit, there will be easier runtime operation for everybody that's using it. And so that was a trade-off that we think makes sense in the context of Istio, because we can kind of take on that pain for a large number of applications that are going to leverage the service mesh. Whereas it maybe doesn't make as much sense today for an individual business application where it's much more important for you to have agility, speed, time to market compared to the operations side of it in core infrastructure.
Yeah. And so you created the Istio as a kind of a solution to bring, I think there was, what was the name again of the services?
Yeah, Citadel, Mixer, and Galley.
Right. Wasn't there one for the certificates? Citadel?
Yeah, that was Citadel. Yep.
Yeah.
So exactly, because basically what it was, there really wasn't a strong need. If you actually looked at runtime, so first off, we did away with Mixer. Mixer used to exist. It acts as kind of a central cache and a central policy enforcement point. We did away with it because we haven't seen folks at the scale where it makes sense yet. I do firmly believe that in some of the larger mesh deployments we get into, we'll see a Mixer-like component return. That's a different talk. There's some YouTube videos that I've given that you can search for about that. But if you look at the runtime stuff, there was really just configure the envoys and issue the certificates. And so we kind of stuck those together into a single binary.
So when you look at organizations adopting, a service mesh at a larger scale, what were the first kind of challenges that you've seen that Istio had, kind of struggled with?
Yeah, there's two categories of challenges, I think, and I'll split them into runtime and administration. So the runtime challenges are that, Istio is situated to deal with a single cluster. Nobody has one cluster. One cluster is a toy. When you have one of a thing, it goes away, then you're out, right? And the fact is that we have multiple clusters. We have multiple physical sites. We have a pretty diverse topology that we're deploying on top of. And Istio is really only situated to deal neatly with a single cluster at a time. And so how do we start to weave a coherent infrastructure on top of a bunch of individual Istio instances is one of the first technical challenges. Because you want a bunch of Istio instances, because if you have one global Istio instance and it goes down, then what's it matter that you have a US East and US West region, because they're both down. And so you want to run multiple Istios so that you're available. Now, how do you actually keep them coherent? That's challenge number one. Challenge number two is the administration of the Istio configuration itself. So, the service mesh brings a bunch of capabilities for traffic management, for security, for observability. Who can change which? You certainly do not want to be able to have an application developer inadvertently or maliciously turn off MTLS for their service or for any service. But out of the box, it can be challenging to do the correct administration. And so, being able to set up who can do what in Istio or with service mesh configuration, taking into account the existing organizational structure and the responsibilities of the different teams at play, is a really hard problem for organizations to grapple with. Those are the two big ones. So how do we take it past one cluster? And then how do we divvy up responsibility and ownership within our organization over the various pieces of functionality that the mesh exposes?
Yes, a lot of people talk about multi-tenancy, but that's not really multi-tenancy, right? That's more, first of all, the delegation of authorities to teams within a large organization. When you have very large teams, you're going to cut it into pieces, and multiple teams are going to be using the mesh, and so you don't want to have a central bottleneck. And so it's all about kind of the creation of different structure, right, within the team.
Yeah, because you want a framework so that development teams can move as fast as they are able to, while being, supported and assured by the central teams, not having to work in spite of the central teams, right? And that's how we see folks that adopt the service mesh realize agility and a much faster time to market, for example, because they can set the right framework in line so that when application developers come in with an application, there's a well-trod path that they can follow, and as long as they're in the path, it's fast, it's easy. The approvals can be automatic. Everything can just go.
And then, do you see people talking about a federation across clusters? Is that also like a big challenge for people?
Yeah. So I don't want to talk. So federation, I don't like, because that tends to be across organizational boundaries. But specifically, how do I weave a coherent service mesh, a coherent networking layer? Because that's really what the service mesh is doing at the end of the day. It's creating an abstract network.
What if you're running maybe on different clouds, right? You're multi-cloud.
Exactly.
Yeah.
Exactly. And so how do I take these different Istios and make them into a coherent mesh? That's a huge problem. Exactly. And so those two problems are exactly where Tetrate comes in with Tetrate Service Bridge, is to solve, taking Istio and operationalizing it across a large and heterogeneous infrastructure, EKS, GKE, GCE, EC2, plus your on-prem data center with vSphere and Red Hat OpenShift, the full gambit, as well as giving you the tools to be able to actually manage it within your organization, bringing your existing identity system, your existing LDAP or Active Directory, modeling your physical infrastructure and letting you assign that ownership with, exactly like you said, not multi-tenancy really, but that delegation, that way to enable a single organization to use the functionality and run fast.
Yeah, very cool. And so I guess the the vision of the Tetrate service bridge was kind of solving some of these issues that you've been talking about, and so why would you need it if you're using Istio today? Why would someone want to use TSB? And you also have a TIB. Is that the acronym?
TID, the Tetrate Istio
TID.
Distribution. Exactly.
Yeah. So what is
Yeah, so if you're just using Istio today, we have an Istio distribution, which is for us, tracks upstream and it gets CVE patches for longer. So we support every version of Istio for 14 months versus the upstream project 6 months of support. We actually have FIPS, the only FIPS verified build of Istio in the world. And that's actually the stuff that now the Platform One team is using as well out of the box, because they're using Istio for encryption in transit. We're in FedRAMP environments. We need to satisfy FIPS. So the fact that Istio and Envoy as the service mesh already have the cert that you can reference there means that all the encryption in transit that you're doing is much easier to prove to auditors in your AO to get clearance to go run. So that's that's just the Istio distribution side. And that, of course, we do things like, the runtime support there when you have production emergencies. That includes some of the stuff like training and similar, so you can actually start to utilize the service mesh. And then, of course, our flagship is Tetrate Service Bridge, and it exists for the reasons that I told you, right? It helps facilitate the service mesh across your entire infrastructure and not just, one Kubernetes cluster or two or three, but the full infrastructure, including your VMs and other traditional workloads that aren't yet microservices. One point that we didn't talk about today is that you don't necessarily have to be doing microservices to get benefit from the service mesh. All the stuff that we talked about equally works for a monolith as well. And thank you, Michelle, for calling that out. That's a wonderful observation in the comments there, right? So Service Bridge helps with that full heterogeneous infrastructure that you actually have in your corporate IT landscape, as well as facilitating the management. How do you actually get it into the hands of the developers, the security team, the networking team, all the different parties that care within your organization, and empower them to use it to go succeed, right? And one thing I'll just point out maybe is a nice idea to end on, since I know we're running a little bit over time. The idea that one of the biggest benefits of the service mesh is that it starts to give these previously disparate teams a single vocabulary to be able to talk about the world together. And so we see that it really kind of starts to break down some of the barriers and help facilitate communication across traditionally siloed groups like the network, the security, the platform, the infrastructure, the operations, and the app teams.
Yeah, no, and we're not running out of time. It's an hour and a half, so
beautiful. We have so much time.
Yeah, no, I know there's so much to talk about. So, in fact, we have quite a few questions from the public. So I'm gonna start bringing one. In fact, from our friend here, Michelle, that was asking, how does Tetrate help a company to deploy their service mesh, and is there kind of any limitation using private cluster, not non-traditional cloud stuff, more on-premise, just like I guess you see with DoD, right?
Exactly. Yeah. So let me take this in two. I'll take the second part first, and then I'll go to the first part. So yeah, we work across a bunch of those kind of exotic topologies is what I'll call it. Things like intermittently connected, entirely disconnected, air-gapped clusters. I think, Nick, we had Platform One run on bombers in flight, right? So all kinds of different environments. So
in fact, you didn't mention it, but Istio supports ARM now CPU, so that's another pretty cool thing.
Yeah, that was a great thing. ARM actually came to us when we partnered with ARM to make sure that Istio and Envoy were compiled, able to run and perform it there. And even further, we actually worked directly with the AWS Graviton team for specific optimizations there on the Graviton architecture. So if you're going and doing ARM stuff there, you're really well supported. Go check out TID for that as well. So how do we? This is a wonderful question. The question around multi-primary versus remote cluster for everybody else, this is actually some specific vocabulary in Istio. So if you go to the Istio doc site and you look at multi-cluster deployments, you will see single primary, multi-primary, and remote, single remote, multi-remote as four kind of possible deployment topologies for Istio across multiple clusters. And the short answer is we don't do any of them, because fundamentally, I don't think any of those are the right way to program Istio across clusters. The shortcoming, let me just, I guess, paint for you the picture of how we do it. And then if we want, we can compare and contrast the specific Istio ones. So the way that we approach it is instead, it's similar to the multi-primary strategy on Istio with a few key differences. So what does multi-primary mean? It means that we're running many Istio control planes. And we want to run one Istio control plane in every cluster that we're running applications. And the key idea is that we want to align our failure domains. So if an app, because Kubernetes is a failure domain, we want to put an Istio in a Kubernetes cluster, and we want that to be a unit. And when an application fails in a cluster, we want to be able to fail over to a new cluster. It's a really useful way to think about the world. I call this a silo, right? So the idea is that we have a set of failure domains that we align together. We call that a silo. We replicate our silo, and we distribute load across the silos to maintain availability. This is the tried and true, this is one of 3 tried and true patterns for high availability applications that we know about, full stop.
So is it an enclave, I guess? Is that kind of the same silo enclave?
It's similar, but the idea is that you want it to be standalone in a cluster by itself and not interconnected to all the other clusters. That way they can fail independently, right? So now then, how do you start to make them talk across clusters? 2 things. One, you need consistent naming everywhere so that you can, and consistent runtime identities so that you can push the same policy to your clusters. And then secondly, and this is really the area where we differ in our runtime topology compared to the Istio website recommended ones, we do not configure Istio to watch the Kubernetes API servers of remote clusters. And that would be the multi-primary model that Istio recommends. What Istio says is, hey, look, I'm in US East, I'm in US West. I have Istio in both of them. Istio gets its configuration from the local cluster, but it'll actually talk to the remote API server to get service discovery information. That's the multi-primary model. That doesn't scale very well, because if our clusters get disconnected, then hey, we don't know about anything over there. Secondly, I'm subjecting every individual Istio instance to the total rate of change of my entire infrastructure, because it has to watch not just its local changes, but also the remote cluster changes. And I only have 2 clusters, maybe that's not that bad. But as you start to imagine, if I have 6 clusters, that's a lot more communication, right? And so we start to get into this n-squared propagation problem. So instead, what we recommend is a pattern that I call application level BGP, which is instead of telling Istio to watch the individual clusters, instead, how does BGP work? I have total knowledge of my local network. And when I need to talk to a host that's not on my local network, I route the request to a gateway. And the gateway knows what the next hop is. We do the exact same thing in Istio. So Istio knows about all the local pods, all the local services. And we tell every Istio instance where there's an ingress gateway to the remote cluster and what services are available to be consumed in that cluster. And if we think about the rate of change of that information is low. How often are services created or destroyed in your clusters? Probably not that often. Certainly, at least an order of magnitude less often than you're deploying pods and deleting pods, right? And so at the end of the day, this is a much more robust way to do it. Istios are individual islands. You create service entries using Istio configuration that tell Istio for a service, hey, it lives over in US East as well, and here's the ingress gateway to US East. Send the request to the ingress gateway. It'll take care of it from there. And that winds up being a really robust and powerful, resilient way to run a multi-Istio deployment.
Very cool. All right, so someone was asking on Twitter, so I can bring it on the screen, but it was asking effectively how lightweight can a Istio deployment be to run maybe on satellites or smaller hardware footprint, edge stuff.
Yeah, so let's be clear, edges. So we're getting there, right? And so things like the ARM builds help facilitate that a ton. For some edge devices, the overhead is still going to be too large, but it's pretty modest. So generally speaking, and part of the problem is that in an edge deployment, the scale is much smaller. So let's talk about the Istio, the data plane itself. The data plane takes roughly 1/3 of a virtual CPU. I'm talking like a cloud vCPU, so that's a decent bit of CPU power, and about 40 megabytes of RAM in a steady state. And that's you can definitely do a lot to reduce that down more, but you're probably not going to get less than about 1/4 of a CPU and maybe 30 megs of RAM. That tends to be a small enough footprint for quite a few use cases, but not for all of them. And I'll note that is that even at that scale, it can still process quite a lot of data there. And what I'm quoting here is the Istio performance and scalability docs. So at 1/3 of a virtual CPU and 40 megabytes of RAM, Envoy can process 1,000 requests per second. So that's still really good. But it might be too large for some edge use cases. Certainly a cell phone, yeah, you're good, right? A car, yeah, you're good. A satellite, probably, but maybe not, depending on what exactly your mission payload is.
No, you're good on the new stuff. And the fact is, hardware is becoming better and smaller, and so it's going to become a non-issue anyways. I think it's more about supporting non-x86 CPUs than it is the size of it. So.
And so let me put it this way: one of the longest tenured Istio developers has been running like a lab setup of Istio on ARM for a long time, on Raspberry Pis specifically, right? So he has like a Raspberry Pi mesh where he runs K3s and Envoy there as well. And so yes, that's exactly right, Michelle. It's Istio and K3s is a wonderful solution. Like Istio and Rancher are great.
So CBW was asking, what's the main difference? And I have never heard of distributed application runtime, so don't ask me to help you because I don't know. So what's the main difference between the two?
So I believe, so let me just be clear here, because there's two different ones. There used to be a different Dapper, and I believe that this is okay. So I want to make sure.
It's a Microsoft thing, I think, but
yeah. So because there used to be Dapper, which was the distributed tracing. That was the original name for the distributed tracing paper that came out. I assume this is talking about the Microsoft.
Yeah, it's a Microsoft
as well,
yeah.
Which is an application runtime. And so the short answer is, I believe Dapper is basically a little bit more similar to a bus architecture compared to like the mesh architecture, right? And this is actually a debate that we had when the Service Mesh first came out. That how is it different than an enterprise service bus, an ESB? And the answer is that a lot of the functionality is very similar, but architecturally it's different because you don't have one party that holds all the data in the middle. You instead have it delegated out, right? And so that gets around some of the traditional problems that an ESB presented. I believe that Dapper, as I understand it, is more tightly integrated with the application itself. So I don't, as I understand it, Dapper is basically a thing that I would opt into as an application to program against those APIs. I don't recall if it's an SDK offhand that you would incorporate as well, as opposed to
yeah, I don't think it's injected
via the sidecar.
That's for sure.
Right.
Yeah, that's probably the largest, most important difference to enable the decoupling of the cyber versus the application teams, right? So
exactly. Yeah, the automatic injection, so that it's always there to exactly.
Yeah, so you talked about tracing a little bit, and Istio has some integration. Tell us a little bit more about tracing and why it's important.
Yeah, tracing is a really valuable way to understand what is actually happening in the context of a specific request. And so or a specific user interaction, I should say, right? So if we think metrics are disaggregated, metrics are aggregated, right? They just give a view of, hey, what happened for just right here, right? Locally. Logging is very similar, right? Logging gives me a local view in a single application what happened. The tracing is really kind of formalizing the idea that I have all my applications print their logs with a dedicated request ID. And then, I can use some system like, Splunk or whatever it is to then link my logs across my applications together by that request ID. And now I can kind of track how this request actually flowed through my runtime infrastructure, right? Tracing, distributed tracing is the formalization of that idea. And so it's a specific and dedicated runtime system for your applications to be able to annotate data about what happened in a transaction and then ship that to a central server. And the key idea is, compared to just being flat logs that are aggregated on a request ID that you need to make sure is passed through, the tracing formalizes that idea with parent-child relationships and draws out that tree of requests for you. So it's really good for understanding and introspecting what's happening in the context of a full request. And the service mesh helps you here by annotating the traces that come through with a bunch of extra information about operations. So they're more rich, right, to be able to debug with. And exactly, if you're looking at Istio tracing, Jaeger or Zipkin are two really powerful tools for being able to do that.
So which one is winning nowadays?
So I see less differentiation here, right? The short answer is that if you have a metrics provider, then probably they have a tracing solution that you use, like Datadog or whoever it is. If you're going open source, then Jaeger is in the CNCF, Zipkin is in Apache. It's both are going to be both support the same runtime format, so you can even migrate between the two. I will say, from Tetrate's perspective, we love Zipkin. We think it's a really, really powerful technology. And in fact, actually, Adrian, who created Zipkin, works at Tetrate. So we're maybe a little bit biased here. But Jaeger is the one that is in the CNCF, and we do see a lot of usage of Jaeger as well. Certainly, a TSB builds on Zipkin as the solution there. At runtime, they're largely interchangeable for folks.
Very cool. All right, so let's see what else we got. So a lot of people, when you mentioned the cycle concept, they're wondering. Some people are wondering maybe if it could have been used for mission. So when you're writing, whatever it is you're building in terms of software capabilities, could that be used, that concept, to build things to be shared across teams, like as a mission software thing?
Yeah, exactly. And so we're actually starting to see this idea develop. And so let me, a really compelling idea that we probably should talk about in a whole episode by itself is the idea that eventually Envoy will probably morph into being an agent manager in some sense, right? Where networking is the primary agent that it does. But exactly like you say, we have this policy enforcement point. We have this proxy where all the traffic goes in and out. I want to start to implement some of my business specific logics and my business specific policy there. And the way that we're seeing this realized is with WebAssembly primarily. So if we think about Nginx, and when I had Nginx and I wanted to go customize or extend Nginx, what did I do? I wrote a Lua script, right? For Envoy, instead, as we're moving into kind of the next generation of technologies, we use WebAssembly for that instead of Lua, and that gives us, the ability to write our logic in a variety of different languages. It gives us better runtime performance. It gives us better safety guarantees. There's a lot of really.
Can you tell people a little bit what WASM is, because I think a lot of people don't know what that is.
Yeah. So WASM is WebAssembly. And so you may think it's kind of weird that I'm talking about WebAssembly in the context of doing like sidecar policy stuff. But WASM was originally developed for high performance applications in the browser, right? So the idea was that we want to start to build applications like Google Docs, like StreamYard, which we use to stream this, more rich and compelling applications in our browser. And because it's being executed by a browser, it has all those safety requirements around sandboxing just like we do for JavaScript, for example, right? And so WebAssembly kind of started life as maybe kind of a next generation API for web applications to target instead of targeting JavaScript. And if you did, you got better performance and similar. But what we've seen is the realization that the ability to dynamically load code that's low level, that's performant, that's lower level potentially even than like Java bytecode, right? Into this virtual machine and execute it quickly and safely is really, really powerful, right? And more performant than traditional proxy extensibility tools like Lua. So because it's really performant, because it's built to be sandboxed and safe, to execute at runtime arbitrary scripts, it was a really nice fit to be able to put into Envoy as the engine to run user-provided scripts or code to do exactly what you were talking about, Nick, which is cross-cutting policy in my organization, cross-cutting business logic that I need to enforce for large swaths of applications. I can start to write into a WASM program and ship that to the Envoy sidecars in the service mesh that need to implement that policy because of the applications they run next to, and have that policy, only where I need it. There's some other ways that you can start to integrate with Istio too, with Istio and Envoy as well. So WASM is definitely the most like hands-on way. And in that way, you can basically deal with the entire request. You want to do stuff to the request body, you want to change the request, you want to do payload transformation, you want to do deep packet inspection. That WASM is your ticket, WebAssembly there in Envoy. And that's a set of projects. You can go to the Envoy proxy repo on GitHub, and there's a set of WASM SDKs for you to write against in Rust, C++, Golang. I think there's TypeScript bindings as well. There's a whole bunch of stuff, a whole bunch of languages that you can compile against and deliver that functionality into Envoy.
Is that how you brought the web application firewall stuff, mode security, into Envoy, or use something else?
We actually went directly. So if you think about Envoy, there's 3 levels of integration that you can do. The deepest level of integration is building an Envoy filter in C++ in the Envoy code base. And that gets you the best performance. That gets you the deepest integration. That's what we did for the web application firewall, the WAF functionality. The next down from that is WebAssembly. And that gets you almost the same level of integration, and that gets you almost the same performance. It gets you maybe about 20% worse performance than if you wrote it in C++ in Envoy itself. But for that 20% performance, you get runtime safety, and you get the ability to use any language that you want that compiles to WebAssembly. I'll point out for folks keeping track that 20% performance overhead is roughly the performance penalty of Java versus C++ for pretty common application workloads, right? So that's roughly if you don't care if the service was written in Java versus written in C++, then you probably won't care if that functionality in Envoy is directly in the proxy or delivered via WebAssembly. Right. And then the third way that you might integrate is the lightest weight way, which is an API integration by implementing an API that Envoy has called the External Authorization API. And that's the least invasive. And the way that works is that every request that comes through, Envoy is configured to send the metadata, not the payload, but the metadata from that request to the authorization server to get back a policy decision. And so that doesn't just have to be, like end user authorization, although it can be. And in Platform 1, for example, we used that to do end user SSO. But you can also implement arbitrary policy. So if you have policy around A can call B, this service can call that service, or only particular headers, only particular signed request headers, assigned JOTs with particular things. That style policy around the request metadata, but not the request body, you can implement with an Envoy external authorization API integration. So those are the 3 biggest ways that we see people integrate with and extend Envoy. And just to round that out, if you're going to use like OPA to do policy with the service mesh, the way that integration works is with the external authorization API. right? So that's how, just to make that concrete for folks
So
that are kind of in the space.
Open Policy Agent for people that don't know, right?
Yeah,
Using
sorry.
Rego. Yeah. Open Policy Agent. Cool.
Yeah.
So I misled you on the previous question because Dapper is actually a CNCF project also, and it's Dapper.io, which I've never heard of before, but it seems to be like kind of a service mesh alternative. It has a pub/sub thing, service invocation thing, kind of does HTTP gRPC, uses PFI and Spire for identity management, open telemetry. They use Zipkin and Jagger too, so I'm just confused as to how it's not a service mesh, I guess, somehow.
Yeah, I mean, my takeaway would be it probably is a service mesh if we're talking, what is a service mesh?
They have a sidecar. I mean, they have a sidecar too, so it's checking all the boxes. But
yeah. So yeah, I will definitely, I will have to go poke around at Dapper a little bit more. I am familiar. I have seen a little bit around it, but I actually am not super familiar with the implementation there. Other than my understanding is it's a little bit more integrated with your application than you because it's primarily exposed to a set of APIs to consume.
And I guess it's a CNCF project now, so
yeah, it is.
Put the link here for people to check it out. All right, so someone was asking also, and I'm gonna kind of rephrase a little bit the question, but sidecar versus a proxy. Why would someone want to use a reverse proxy instead of a proxy, for example?
Yeah. It really comes down to how the traffic is handled. The shortest answer is that sidecars tend to be kind of a universally better model, except for where you don't control the client. And so if you don't control the client, like for example, when you're a website and clients are connecting through a browser, then you want a reverse proxy, right? But for systems where we can control the client and or the server together, a sidecar proxy gives us almost universally better benefits because we can do things like resiliency at the application. We can have things like retry and service discovery happen from the application itself rather than from a central point. And that winds up giving us a much more robust system. We're more, for example, we're more tolerant to a variety of partitions. We're more resilient because individual clients can do self-healing behavior as opposed to just being kind of dumb and just sending a request to a DNS name and hoping for the best, right? Those are the major considerations. There's also some security implications there. So how do you connect from the reverse proxy to the application backend? And how do you secure that connection? How do you convey end user identity over that connection, as well as potentially an application identity in front of the reverse proxy? Because again, we want those 5 checks: encryption and transit, application authentication and authorization, end user authentication and authorization. So if we're doing those things at every hop along the way, it can be a little bit more challenging when we have a reverse proxy in the middle versus doing it with a sidecar. So at the end of the day, every deployment is going to have both, because you need to get external traffic into the mesh, and an ingress proxy, which is a standard reverse proxy, is the way that you do that. But inside of your infrastructure where you can control the servers and the clients, you ideally a sidecar is going to give you a better set of trade-offs than reverse proxies.
Right. So we didn't talk about Ebpf, so I want to talk about Ebpf before we let you go, and I always let you have the last word after that too, so we're going to do both of that. But tell us a little bit about what is Ebpf and why it could potentially bring value on top of the mesh as well.
Yeah, so Ebpf is Berkeley packet filtering. It's basically a virtual machine that lives inside the Linux kernel, and there's a whole bunch of hooks all throughout the Linux kernel to be able to execute an Ebpf program. And the biggest place that they get used is in the networking stack. That's why it's packet filtering to begin with. And so the idea is primarily that we can take functionality that Envoy does in user space and move it into the kernel, into kernel space to be executed by the Ebpf virtual machine. And as a result, we get better performance. And the reason is because we don't have the context switch, because Ebpf itself is a restricted language that we can execute very quickly. The Ebpf VM does cool things at runtime, all that stuff. So the primary way that I think about Ebpf is as an accelerator, right? It takes existing functionality that we were doing in Envoy and user space and makes it go faster by pulling it into kernel space or doing other bypasses. For example, you can use Ebpf to do a fast path to skip the network stack between the application and the sidecar. You can use it to skip the network stack when you're talking between two applications on the same host. Those are nice optimizations, but they don't apply in every case. The primary idea would be like, can we pull HTTP parsing out of Envoy and into the kernel to make it go faster? So that's where Ebpf is coming from. It gets caught up a whole lot in Cilium Mesh and the fact that Cilium Mesh has a host-based proxy model as opposed to a sidecar-based proxy model. And so all the stuff that I talked about earlier, the noisy neighbor, the confused deputy, and the shared fate outages that apply for a host-based proxy apply if you're doing that host-based proxy in the kernel too, right? And so I want to separate those two topics. So sidecar versus host-based deployment model, you can do both in Istio, but there's security trade-offs and runtime trade-offs for that. Then there's the idea of Ebpf, and that's an accelerator. And to the extent that, folks like Cilium Mesh are able to make Envoy go faster, and sorry, my headphones just died. To the extent that they're able to make Envoy go faster, we'll incorporate it into Istio, into upstream Envoy as well, to be an accelerator for us.
Yeah, so some people kind of are confused whether or not it kind of competes, right, with do we need both a Service Mesh and Ebpf, since you can do a lot of the stuff allegedly, you can do with a sidecar Envoy proxy directly on the kernel side with Ebpf? Like, what would you say it is not competing, I guess, or is it competing, but we don't know yet how good is it going to be?
Yeah, so it is competing, but it's still early days. Fundamentally, I see it as a below the line technology, right? And we will see in the fullness of time a single service mesh that'll integrate with multiple data planes. So, and what I mean by that is Ebpf is just another data plane, right? Some of the functionality we put in Envoy, we can move into Ebpf, not all of it. And so I personally, I see it as an acceleration, but it's below the line functionality, right? One day there will be an Istio patch note, maybe it'll be an Istio.20, right? Well, I don't know. There will be a patch note that says Istio sidecar is now 20% faster, right? And it doesn't really, why should you care how, or actually what it'll say is Istio sidecar is 20% faster if you have a Linux kernel that's this version or newer. Right. And so that, whether or not that, but fundamentally it's a below the line technology, right? When it is mature and ready, we'll ship it as part of upstream Istio and we'll get acceleration out of it. But it's not, fundamentally it's not the reason that you should pick one mesh or the other or not, because the answer is like, for some applications that are incredibly performance sensitive, we'll probably only do Ebpf, or maybe we'll do a user space IP stack with Envoy. If we have Envoy plus DPDK, there's a good chance that's as fast. There's a bunch of different ways to skin the cat. If you actually want the best performance, you shouldn't use a proxy at all. You should use gRPC, and gRPC supports the Envoy APIs. So you can point a gRPC application with no sidecar at an Istio control plane and get 90-ish% of the functionality, in particular encryption and transit and the traffic control and authorization, out of just the gRPC server itself with no Envoy at all, right? And that would be much higher performance than even Ebpf. So there's a spectrum of solutions here. We're going to start to see that a single mesh will drive multiple data planes because different sets of applications have different data plane needs. Kafka that you gave earlier, Nick, was another great example where we're pushing the enforcement point into the Kafka server itself because it makes sense for all the connectors, right? That's yet again another data plane, right? But you can imagine that we would still point that at Istio.
Well, you gave us so much information today. I think people learned a ton. So first, I wanted to thank you, but I'm gonna give you the last words. It's not really the last words because after you talk, I'm gonna tell people who is coming on the show next after you.
Yep,
But
yep.
it's the last meaningful words before I let everybody go. So first, I wanted to thank you for being here and all the work you've been doing for the open source community for so many years. People don't realize kind of all the people involved behind all the tech, the cool stuff we use. And I love to criticize people's work, but in this case, you guys have done an amazing work. So I wanted to thank you and let you share your last thoughts with the group here.
Yeah, hey, thank you for having me along. I love to get to talk to the crew. We have a phenomenal audience asking great questions and giving great answers. So thank you everybody for spending time as well. I love to talk about this stuff, so ask me about it on LinkedIn or Twitter, Zack Butcher everywhere on GitHub too. And if you're looking at doing this in production, if you're looking at doing this for your organization, for your government, and you're hitting some of the challenges around using Istio itself, or some of the management problems, or you just don't even know quite where you're starting, come chat with us. We would love to come help out. Email info@tetrate.io, email Zack@tetrate.io, and we'll get you plugged in and help there. Nick already plugged academy.tetrate.io that has a ton of free training there. So if you've heard this and you're interested in Istio and Envoy, but you don't know for sure yet about it, go check out academy.tetrate.io, and there's great free training there for you to pursue as well. So thank you, everybody. I've had a wonderful time, and I hope everybody has a great day. And thanks for having me, Nick.
Thanks so much for joining. So in the next episode, we're going to have Mike Fraser, the CEO of Refactor, who sold his companies to Sophos. We're going to be talking about shifting left cyber into development teams, and what does it feel like to sell a company to a larger organization, and what kind of control you end up losing, and what kind of issues you may be facing, and kind of what kind of lessons learned. I know very well that too, having sold a few companies myself too. So we'll be talking about that next week and the week after that. So the next week is Mike, the 10th, the 17th will be Prakash, the CISO of Club Bees, joining us on the show, talking about cyber, and maybe I'm gonna ask him a little bit of questions regarding the tech debt of Jenkins, and what he's been doing to fix some of the plugins and some of the legacy stuff there. And God knows I've been vocal on Atlassian for the last 2 years, looking at some of their vulnerabilities there as well. And then you'll see we're going to get a lot of amazing guests after that, including Megan Stanford. We're going to have Sanjay, the CEO of Traceable.ai, join us as well. Lots of people. We're pretty much booked until August, believe it or not. It's pretty insane. If you have cool people that you want us to have on the show, always shoot us a note. We're launching a new website. It's not really ready from prime time, but I'm going to give you a sneak peek to it in the nickofTime.us, like United States, in the nickofTime.us, if you want to check it out and tell us what you think. We're still working on it, but it's a pretty amazing work done by Nerman, funny enough, that's helping us, and that shows you like all the gems we have in the Air Force and Space Force. So thanks everybody for joining. We'll see you next week. Stay safe. Bye-bye.